Let's talk about one of the most bizarre, most controversial episodes in the history of modern science. Seriously, it's a story packed with these unbelievable promises, a whole lot of broken rules, and ultimately a scientific idea that was just cast out into the wilderness. We're going to dig into what really happened to cold fusion.
So picture this. The year is 1989, and the world is suddenly told that the answer to all of our energy problems, well, it doesn't need some massive billion-dollar power plant. Nope, it could be done with a simple device that fits on a tabletop running at room temperature. I mean, this was the revolutionary promise that just completely took the world by storm.
And this incredible promise, well, it kicked off the first act of our story. It set the stage for an announcement so huge it was going to shake the entire scientific world right to its very core.
Now, what's absolutely wild here is the timeline. The entire public drama, from that first earth-shattering claim to the final crushing verdict from the establishment, it all went down in a mind-bogglingly short 5-week period. It was a complete and utter whirlwind.
Okay, so let's meet our main characters, Stanley Pons and Martin Fleischmann, two chemists from the University of Utah. Their claim was, to put it mildly, extraordinary. They said that by running an electric current through a jar of heavy water using a special metal called palladium, they had achieved nuclear fusion, the same thing that powers the sun, in a jar.
The stakes, you couldn't get any higher. This wasn't just some abstract academic finding. If these guys were right, it meant a brand new chapter for all of humanity. We're talking clean, limitless energy. The feeling at the time was literally that the world's energy problems were solved. Just over. But, and this is a huge but, the way this discovery was announced immediately threw up some major red flags. And that brings us to the second act of this saga, where the normal, careful, methodical process of science was just completely tossed out the window.
This quote right here really captures the mood perfectly. Instead of quiet, careful labs trying to verify the work, what we got was just chaos. It was described as a feeding frenzy, with labs all over the world rushing to confirm it, then retracting their claims. It was just science gone berserk.
And this slide, it illustrates the core problem perfectly. You see, normally science has a system. It's called peer review. You do your work, you write it up, and then you send it out to other experts who try their best to tear it to shreds. Only if it survives that trial by fire do you go public. Well, Pons and Fleischmann were so afraid of getting scooped that they just skipped that whole part and went straight to a press conference, which lit a media firestorm and bypassed the entire scientific process. And this frenzy wasn't just happening in the US. Oh no, this thing went global. Over in Italy, another key person enters our story, Professor Francesco Scaramucci. He's described as a man of unflinching integrity, and when he heard the news, he decided he had to try and test it for himself, but with his own very clever twist.
Scaramucci's method was it was elegant and different. He called it dry fusion. He took some titanium shavings, pumped in some deuterium gas, and then, and this was the genius part, he shocked the system by cycling the temperature up and down really fast with liquid nitrogen. And the results? They were stunning. His detectors picked up what he called substantial bursts of neutrons, the absolute telltale signature of a nuclear reaction.
So this apparent confirmation from a respected lab in Italy just added more fuel to the fire. But at the exact same time, the mainstream physics community was getting ready to push back, hard. And this brings us to Act 3, the scientific case against cold fusion. Okay, so here's the fundamental issue. Basic textbook physics tells us that getting two deuterium nuclei to slam together and fuse is incredibly hard. I mean, they're both positively charged, so they repel each other with an enormous amount of force. It's like trying to smash the north poles of two super strong magnets together. The universe just doesn't want it to happen.
So, how hard is it? Well, physicists ran the numbers, and what they found was just staggering. The odds of fusion happening in that jar weren't just low. They were off by 40 to 50 orders of magnitude, and that's a number so big it's almost impossible to wrap your head around.
So let's just try to put that into perspective. 1 order of magnitude is 10 times. 2 is 100, 3 is 1,000. When you get to 50 orders of magnitude, you're talking about a 1 with 50 zeros after it. That number is bigger than the number of atoms in a grain of sand. It's just a level of wrongness that, according to the laws of physics, meant this wasn't just unlikely, it was functionally impossible.
But, okay, let's just pretend for a second we can ignore the theory. There was a second, even more practical problem. You see,
when fusion happens, it leaves behind fingerprints, very specific nuclear byproducts. And in the cold fusion experiments, those fingerprints just weren't there.
And this is where the math really falls apart. Real, known fusion reactions produce a very specific recipe of stuff, including a shower of high-energy neutrons and a substance called tritium. So on one side of the scale, Pons and Fleischmann were claiming this massive amount of heat. But on the other side, they could only find the tiniest, barely there traces of the stuff that should have been created. The books just didn't balance.
And that leads us to probably the single most damning quote of this entire affair. A physicist at Caltech did the calculations, and he realized that if the amount of heat Pons and Fleischmann were claiming was real, the flood of neutrons coming out of that jar would have been lethal. His conclusion was blunt. If it were true, they'd both be dead.
So, it seems like the case is closed, right? But here's the thing about science. It's filled with surprises. The whole history of science is basically a story of prevailing theories being proven wrong. So you have to ask, could this have been one of those moments?
And there were recent examples that gave people a reason to at least pause and listen. The discovery of high-temperature superconductors in '86 totally blew up what physicists thought was possible. And another discovery, the Mausbauer effect, had shown that putting a nucleus inside a crystal could actually change a nuclear reaction. So, you see, there was precedent for weird things happening.
But that willingness to listen, it had a shelf life. And it ran out just 5 short weeks after that first press conference. And that brings us to the final act of this whole drama, the public execution of an entire field of research.
The final showdown took place on May 1st in Baltimore. It was at a huge, packed meeting of the American Physical Society. A team from Caltech got up on stage and presented their findings. They had tried rigorously to replicate the results, and they had analyzed every last claim. The result was described as a perfect slam dunk that just dismantled the case for cold fusion piece by painful piece.
And that was pretty much it. After that Baltimore meeting, the door wasn't just closed, it was slammed shut and bolted. Cold fusion was no longer considered a legitimate area of science. It became a pariah, totally cast out from the establishment.
But that public takedown wasn't quite the end of the story. Like any idea that promises so much, it didn't just vanish into thin air. It went underground. Today, there's still a small, dedicated community of researchers, often funded quietly by major organizations who continue this work. They just call it something else now, like new hydrogen energy.
And all of this leaves us with a really fascinating and tricky question to think about. The whole cold fusion saga was, a chaotic mess, kicked off by breaking all the rules. But sometimes radical breakthroughs require breaking the rules. So it makes you wonder, when, if ever, is it actually the right thing for science to break its own rules in the search for the next big discovery?